Humans have worked with petroleum for thousands of years. For example, using natural asphalt to waterproof boats and baskets from California to the Middle East. But once we humans learned to draw oil from deep underground, it became something else entirely, a powerful energy source. And we reshaped our global society and economy around petroleum. In this video, we'll talk all about petroleum, from its formation deep underground to how we extract it, and then its role as a commodity as it circulates around the globe. And then finally, the consequences of basing our economy on petroleum. Petroleum, also known as crude oil, is a liquid fossil fuel. This means that it comes from the decayed matter of ancient living organisms. So petroleum in specific comes from ancient marine organisms, ocean creatures that were buried and then transformed over the span of millions of years. So we can see in the images here, the ocean creatures become buried by layers of sediment, and then eventually they become oil. And that oil, or petroleum, is then refined into commodities, so products that are bought and sold, like fuels and plastics. The transformation into petroleum occurs because the burial under layers and layers of rock causes heat and pressure to build up. The matter then breaks down into oil contained in a layer called the source rock. The pressure also squeezes the oil out of the source rock into permeable layers above it. And these permeable layers, also called reservoir rock, contains water in their pores. And since oil is less dense than water, the oil rises. And it'll rise until it meets a layer that's impermeable called a cap rock, trapping the oil underground. So this picture on the right is an example of an anticline trap, meaning the cap rock is folded. So it creates this little dome for the oil and natural gas that comes with it to collect. And this is an example of a fault trap. If you recall the video on plate tectonics, a fault is a boundary between plates. So this can cause the layers of rock to not quite line up, which means that if there's permeable rock next to impermeable rock, then there might be these nooks that oil and natural gas can get trapped in. It's from these traps that humans extract petroleum, and this extraction is actually historically pretty recent. We humans have only been doing it for about a century and a half at this industrial scale. And extraction technology like drilling is pretty wild when you think about how it connects geologic deep time, so millions and millions of years, to our current systems of energy and production. Pictured here are two forms that drilling can take. On the left are oil rigs on land, and then on the right is what oil rigs at sea usually look like. Because petroleum forms under specific conditions, it is found and extracted in specific places. So this is a map of oil-producing regions around the world, centered in areas that were once underwater. And petroleum is often refined in places that it isn't extracted from. So crude oil is shipped or piped to different places. And this map on the right shows shipping routes for petroleum, including locations where political control or conflict over shipping can occur due to geographic conditions like narrow passageways. So then crude oil is refined into various products, including gasoline, diesel and jet fuel, asphalt like for paving roads, and then petrochemicals, which become plastics or synthetic fibers. And so all of this is to say that many everyday commodities now contain petroleum derivatives or petroleum products. And this graph on the right kind of shows the percentages of how that breaks down. So it's mostly going towards fuels. So the most common way that we interact with petroleum in our daily lives is through our mobility. Petroleum is the current basis for human mobility in general. And this includes local travel, like our commutes, represented in the map of the Bay Area on the right. And it also includes global transport as well. For example, cargo ships, airplane flights, that kind of thing. Our infrastructures, so the technologies that allow us to move, are both built from petroleum products, like asphalt in our roads, and powered by them, like our fuels. And this is to say that there is this geologic basis to our mobility. The lithosphere is enabling and powering the ways that we move around. But our petroleum based economy and mobility system is not without its problems. There are environmental impacts from the extraction and consumption of petroleum. For example, there's oil spills on land and water, which is, of course, an accident. But there's also increased carbon dioxide in the atmosphere, which also gets absorbed by the oceans. And this isn't really an accident. Most of us know that driving isn't great for the environment, but it's also often the most convenient way to travel today. And these environmental impacts are uneven. And when I say uneven, you should be thinking spatial patterns, right? So the risks of producing petroleum are localized, for example, through spills. But the risks of consuming petroleum are globalized, for example, the CO2 that gets put into the air. So this is kind of lopsided, right? For folks who are producing petroleum, they have to deal with the risks in their local area. But when it's being consumed, when we are benefiting from the combustion of petroleum products, then everybody has to deal with the risks. And this map on the right shows countries that produce and or consume petroleum at high rates. So when the green circles go past the black circles in the map, that's when a country is consuming more than it produces. So this visually represents an uneven spatial pattern. And I want to point out as well that both of these are the result of human demands and practices. It's not some natural outcome. It's the result of a system that some humans have built and maintain. Most of us have come to recognize the issues with basing our global economy on petroleum. So today, our societies are experimenting with energy transitions toward alternative sources of energy. And while in general we are using more energy, as you can see in this graph, we're also looking for sources that aren't from fossil fuels. So like renewable resources, including wind and solar energy, but also sources like nuclear energy, which comes with its own set of problems, but carbon dioxide is not one of them. And consumers are also starting to seriously consider electric vehicles. So new light-duty vehicle sales in the US are now 20% hybrid or electric, which is up from like 5% a decade ago. But we also need to read these two graphs together. It's important to remember that if you drive an electric vehicle but still get your electricity from fossil fuels, then your travel is still powered by fossil fuels. But energy transition is not just about replacing fuels. It's also about reorganizing space, infrastructures, and economies. So, for instance, where do we build solar farms rather than oil fields? Or how much street space do we allocate to electrified public transit rather than personal automobiles? It becomes this sort of opportunity to rethink how space is structured and also how we relate to the lithosphere and to our planet. And even if we succeed in transitioning away from petroleum, oil still has an afterlife. Petroleum products will continue to shape our planet long after we stop using them. We can see this in the carbon dioxide lingering in the atmosphere, the plastics in the ocean, the microplastics in our bodies, and the layers of waste accumulating in the ground. The image on the right shows geologic time as layers of sediment, including rocks and organisms built up over millions of years. The very top layer represents the era we humans are creating now, often called the Anthropocene, the period of time when humans have become a dominant force shaping the environment. This layer will look unlike any other because it holds traces of our carbon and our waste. But I want to conclude by saying that it's not my intention to make anyone feel guilty. My goal is to show how the lithosphere connects to human life and society. And so the petroleum economy was and remains a human choice. But this also means that we have the power to choose differently by building different systems and different structures. So thank you for watching, and I'll see you next time.